Good morning, class. Today, as promised, I'm going to be explaining the slant asymptotes. Right? So first, we're going to go through the example, which you already should have copied in your notebook. And then we're going to solve this little practice problem. Here we go. Okay? So first things first. Find the slant asymptote of this equation. Now, before we can actually work with it, we have to make sure of three things. Number one, very important, we have to make sure that it has been simplified, okay? That means that we cannot cancel anything else. In this case, it's already been simplified, so we're good. That's step number one. Step number two, we have to make sure that our exponent is, let's see if we can focus here, yes, is exactly one more than the one in the denominator, okay? That is very important. It has to be exactly one more than the denominator. All right, that's what it says so here. Because the degree of the numerator, 2, is exactly 1 more than the degree of the denominator, 1. And x minus 3 is not a factor. That's what I was talking about, that it has been simplified as much. Well, it tells us that we will have a slant asymptote. So once we have taken care of those two things, we have established that there is, in fact, a slant asymptote. And then the only thing left is to divide, okay? So we divide the denominator by the numerator, once again, with synthetic division. We're already pros at this. So we divide, and we have that our equation would be something like this. 1x minus 1 minus 8, which is the remainder, divided by x minus 3. Now this, we don't really care for. Our result would just be 1x minus 1. Okay, so this right here, this is what will be the equation for our slant asymptote. Okay, that's what it says right here. Equation of the slant asymptote is y equals x minus 1. So that's it for this short video. Now I'm going to begin recording the other video for the example of this. I'll see you guys soon.